Hello everybody, welcome to this tutorial on how to draw some threads in AutoCAD, some representations of threads. I made this video, I don't know, like 7 years ago or 6 years ago on a channel that I have no idea how to access to or get to, so I'm going to redo it and I'm going to add some things to it. So this is the exact same thread, so you can watch that other video. You just search up AutoCAD thread tutorial or something, and it'll show up, but I'm going to recreate it and add a little bit more. Alright, so let's break this down. So this is our thread. This is the label for a thread or annotation. This is the major diameter. This right here, this 9, is our threads per inch. This is the type of thread, and then we have class of fit right here, and then the A or B means A is external and B is internal. So if you see B, it means it's actually drilled out and then tapped. In this case, we're actually threading a bar. Alright, so let's start off with the length. Length is not given. You'd see the length over here somewhere. It'd be like x2, something like that. No idea. I'm just going to make it 1. So now I'm going to go up the major diameter, which is 0.875. Alright, so that is way too big. I don't know what I was thinking there. Alright, so let's say this thread is 3 inches long. That would make a lot more sense. Alright. Now, we break it up by pitch. Pitch is always 1 over the number of threads per inch. So our pitch is going to be, I'm just using the copy tool here, pitch equals 1 over 9. Yes, I didn't use all caps, but that's going to be okay. Alright, so what we can do is actually offset this. So a little bit different than what I did in the other video. I'm going to offset it this, so O enter 1 over 9. And I'm only going to do a couple. There we go. That's our pitch, or from point to point, if you want to think of it that way. Now come down to your polar tracking, right click and go to 30. And because this is a UNC thread, our standard is going to be 30 and 30, just like that. And the way this thread works is you have to have some sort of offset on the bottom to actually give the thread that corkscrew feel. So what I'm going to do is actually delete these now. Now that I have a couple, and we could go across. Notice I left the first one blank, if you want to think of that pitch right there. Now this one we're going to go over half P, which would be 1 over 18. Easy way to always divide fractions is double the denominator. So 1 over 18 will give me right there in the middle. Now this one's going to be just like the other video. So once I have done that, I can go ahead and copy this over 1 over 9, or you could do the offset method. It doesn't matter, you could do it a billion ways. But you have to have that 1/2 right there, that half P right here. And I'm going to point to it just so we're all on the same page. I'm going to copy that right there. This has got to be 1/2. I don't even know how AutoCAD does that. 1/2 P, which equals 1 over 18. Again, thing I tell my students all the time, just double the denominator if you ever want something to be half. Since P is 1 over 9, double the denominator. There we go. Alright, now take this line and do your 30, and your 30, and your 30, and your 30. And you can keep doing that. You can imagine doing this by hand back in the day would be absolutely excruciating, and I did do that in high school, and it was. Now we don't really have to do that anymore. Alright, so now I'm going to finish off the end. I'm not really sure why I didn't do this to begin with, but I didn't, and that's okay. I was thinking of the schematic with the chamfer in the end. And then basically what you're going to do, these are your crests, these are your roots, and you basically go crest to crest, root to root. So, like this one, for instance, is going to go there. This one's not even showing up, so it doesn't really matter. You just go like that. And you really only have to do this once or twice. I don't know why I'm doing it so many times. Go ahead and delete that. Go ahead and delete that. Delete all our little construction lines here. Gonna go ahead and trim this up. Grab the whole thing. And then this is where you can just, boom, just keep copying it all the way down to the end. So copy, and I see I missed a chunk. That's alright. Just gonna overlap. Doesn't really matter. Go ahead and right click trim. Actually, you don't need to, you can just delete it. Alright, now the last part is this chamfer, and I have a problem here because I don't like this. I don't like how this looks. I don't like putting chamfers on when you only have half a thread. What we really need is a whole thread. So what I'm going to do is actually come up right here from this point and get rid of everything on this side. This is what I want. Basically what you're going to do is go down here to your 45, and from the minor diameter, which is this point, we got our major at the top, minor here. I'm going to go at a 45 until it hits. I'm going to do the same thing down here. So I need to go straight across and then 45 until it hits. Now if you can visualize this, this point has now been shaved off to this point. And actually, you can actually grab all three of these by just highlighting them, highlighting all three lines, and go just like that. You can do the same thing. Can't do the same thing for these, but I can grab these two, put them right there, and then take this and push it back up there. Lots of different ways, but as long as it looks like this when you're done. And again, we didn't give it a length, but you could over here. And then now it's time to make that nice little fancy end thing. I'm going to go ahead and delete this. Hopefully you got that and understood that. And then you got to think that this thing was a bar, a solid bar at one point. So this is just arbitrarily pick this. I'm just going to go over 0.5. I'm going to go up, over. Now I'm going to cut it in half. Cut this in half, and then I'm going to draw another line right on top over here and cut this in half. So basically making a grid. I'm going to do SPL. If you actually make squares, I think it looks better, but you know what, for this purpose it's going to work just fine. Alright, so I'm going to do that just like this. So you can see how I connected those three with a spline. I'm going to hit enter, and then this spline right here like that. Now this, I don't like how this is going to be hitting this part, so I'm going to take this whole thing and just push it over a little bit further more, about 0.25. I'm going to go ahead and delete my construction lines, and basically you only need this bottom part like that, and then this like that. So you can do some, really, I'm just rushing through this, but if you did squares, I believe this will come out flatter and look a lot nicer, but you know what, it's the same representation, it's gonna work. So I'm gonna do a hatch here to show that this is material, just like that. I'm just gonna click right there, and I usually like to keep things nice and consistent with line types and stuff on different layers, but in this case I don't want to make a new layer here, but I don't want these to be nice thick bold lines like I have. So what I'm going to do is actually just click them, go to the home tab, come over here, and right now everything's by layer. I'm going to change that to default. It's going to give me a nice thin line. If you don't see how I've set this up, you can always go into your layers and you can see that I have a line weight of 0.35 for my 0 layer, which is going to be most of my visible lines. And then finally, I always like to make my own center lines. Not a fan of the centerline tool in AutoCAD. It's just a repeating thing, and it's just, I just don't like it. I like to make my own. So, and because I like to make my own, it's because I think that every single one is relative to the size and shape of your part. So here's a really simple way to make a center line. I just drew a line. It's a different layer. It's green. It's lighter. You pick a diameter or a radius right here. So I'm going to do 0.1. And I'm going to enter again, and I'm going to do 0.2. And so what that does is gives me a mark in the middle, and then a gap here that I can trim. So if I TR enter, right click, and then delete the 2 circles. And this is my 2xx rule. So the center mark right here is 2x, and these gaps are x. 2xx. You can take this and you can actually make it a group if you want, so you don't miss a part. Just go up and put it, bam, right there in the middle, and then you can kind of move it and shift it over so it's centered. We could find the center, but you know what? That's gonna work right there. Hopefully that's not too hard to see, but again, for video purposes, we can go ahead and make it, I don't know, red, something, anything different. Totally up to you. Alright, so that's the detailed. That's the hard one. That's the one that takes the longest, and you know, some people like it. Detailed. Alright, now it's time for schematic. So I'm going to take the same size just to be consistent so this looks nice. Jump back over to the right layer first of all. And I could copy this down, but I'm not going to. I'm going to go through the steps again. 0.875. Length is not given, so this one I'm actually going to go over like that. Like this. Like this. And this is way, way easier. Offset 1/9. That's our pitch. And instead of drawing the slope and that curl and all that fun stuff, what we're going to do is jump into this polar tracking. And what you do is you go down just like before, but you do the exact same thing. I'm just going to do it in one thread. Like that. TR, enter. Trim that up so we got our major and our minor diameter. I'm going to draw a line from root to root just straight up like that, and I'm going to delete those 2 triangles. Now I'm going to click on this line, and this is, again, I'm going to just override this, and right now I'm at point. I'm just going to visually make this really bad, even though I'd have no idea what this would print like. But yeah, as you can see, you zoom out and it looks terrible, but you can see it. We want that line in the middle to be thicker. And then basically what you do is you just copy it like so all the way to the end. Now let's just stop right there. Sometimes you'll see a bolt that actually has a part, you know, that's not threaded. It doesn't thread all the way to the end, which is, you know, the same thing this one's doing, but you know, that would be, let's just copy this down, my understanding of it. How long is this? So we're at 2.1 repeating. I wonder if this was exactly 2. Alright, so let's say the thread was only 2. Now the bolt might be longer, but there we go. So now we have an actual representation of the length of the thread on this one. This one's just going the whole way. I don't really know what we're doing with that. Now, right here, I've seen different books, 2 different ways of doing this. One, bring this across and then go up on whatever angle, and you just go to your chamfer. I've seen that method, so it looks like this, even though that's not really a 45. And I've also seen this method where you take this point and then you switch over to 45 like this. So I'm not sure which one's right. This one doesn't actually line up with you're a little bit off with the minor diameter, but it's at a 45, and the other one you're not technically. Kind of like the other one, even though it's not a 45, just because it lines up, but we'll just go with this one. Then, since we never want to work harder than we have to, I'm going to copy this down, delete that, and go ahead and copy this as well. So now we have a schematic thread, and we have a detailed thread. So let's go ahead and put this here. Schematic. Awesome. And then finally, the easiest one, which is the simplified. Just going to copy this whole thing down. This time we're not going to do that. So this one, I actually want this to be at that minor diameter. So I'm actually going to come up and change my chamfer. Even though it's not truly a 45. And this is the easiest one. You get rid of everything except the chamfer edge, because the chamfer edge shows like this. Let's say we got the exact same thread. Like this. And then what we're going to do is go ahead and grab the hidden line. So if you don't have a hidden line layer, you just click hidden, click here, line type, you load up hidden. You get a scale that you like. You can always rescale it on site too, but you just put it in line just like that, and then you're good. So the hidden line represents the minor diameter. You got your chamfer, you got your length, everything's good. Now let's look how we would show these at an end view. Actually, let's go ahead and put this here. Simplified. Spell that right? Simplified. Alright, good. Alright, this is even easier. I'm just going to come over here. So I'm in the circle command, C enter, and I'm just grabbing that center point. I'm going to come over here. I'm going to move this. Actually, let's move this now. So C enter. Don't click, but just put your cursor on top, and then that little projection line comes up. And then I'm going to, oops, and I'm on the wrong layer, but we can fix that. So basically I want the major diameter. We could just type it in, but I'm all about projecting my lines like so. So this one I've also seen differently. I've seen where people show the minor diameter like this, and they show it visible, because you would actually see this. Then I've also seen people make this hidden, because you don't actually see this and you want to show kind of separating it from either way. So I've seen it both ways on multiple drawings. For me, I think either way is acceptable. It's when you do the minor diameter, that's when you get a little different. Alright, so what I'm going to do is copy my center line over because I like to do that. And since I grouped it, I got to ungroup it. Ungroup. And what I'm going to do is a circle. And I know my major diameter is I know my diameter is 0.875, so I'm just going to go 5 because I know that'll be bigger. And then I'm going to delete this and move this into like that. And then I'm going to mirror it. And I already don't like, I don't know, maybe I do like it. No. I'm going to draw another circle. I'm going to use the extend tool, EX, right click, and just make these a little bit longer because you never want your center mark and your extensions to be remotely the same. And I think those were. There we go. And guess what? It's the same for every single one. You can see how I shifted those ones over. It doesn't matter. Alright, perfect. Now, what would this look like internally? Well, internal threads are exactly the same for the most part. I'm just going to make a box. Let's say this is our chunk. And we always want to show internal threads as sections. So what I'm going to do is copy this just over here. And then I'm going to mirror it. Like that. Now, internal threads don't have the chamfer, because if you had the same chamfer as this, you'd actually make the hole smaller, which doesn't make any sense, and then the bolt wouldn't even fit in there, or whatever you're trying to screw in there. Alright, so what I'm going to do is just put it right, just like that, right in the middle. And let's try to make it look a little nicer, so I'm just going to go right to the edge. Trim this up. And then just copy this. So this is going to go clear through. Clear through to the other side. And notice how I flipped it. I flipped it because it's a section. In sections, you cut in half and then you get rid of the other side. And since we're getting rid of the other side, or the front side, we're actually seeing the back end, which is all the crest going the other way, which is why it is flipped and going the other way. So same thing, I just made it like that. And just push that over like that. And there you go. There's the internal thread for clear through. Now, if we want to make the schematic one, let me just bring these down a little bit. Just using the move tool. Grab another rectangle. Maybe not make this one so big. Looks good. And this one's going to blow your mind. This is exactly the same. Identical. So let's say in this one, let's mix it up. And you're probably not going to do this with a detailed thread anyways, because it's going to get really weird. Let's say the thread doesn't go all the way through. Maybe it only goes an inch or something. It doesn't really matter. What you need to show is actually that drill, how you drill it out at the minor diameter and then you tap it. So right here we could say, this was the length, whatever it is. I'm not going to show that, but right here we actually want to show, and I've seen it in many books that it's supposed to be a fourth. You're supposed to go a fourth extra. Whoops. So imagine this being the hole that was drilled first, if you want to picture that going here, and then the tap goes in and actually threads this. And then we show the point, which we'll do our 30 and 30. So that's the, whoops. Make sure that's on, 30 and 30. That represents the drill bit point. Should always show that because it might affect your part or whatever you're making. So you can see here the thread's only from here to here, so I need to make this smaller and ungroup it. And this time I'm just going to pull this back to half. Pull this back to half. That way I know it's the same. And then take it and move it into place. And then what you can do is actually click on these, move your cursor over, and actually give it a length, an additional length. So then I added 0.1. Click here, 0.1. So we're learning all sorts of fun things today. 0.1 was not long enough. Here we go. Alright. And then simplified. The exact same thing. Yes, you're supposed to thread it before I move on. And yes, I know this is not in the center. That's not really the point. Okay. And then finally, Schematic, which is kind of weird. It's not really weird, but it's a little bit different. Just grabbing the same box, even though it wasn't a very good box. But now Schematic is going to look a little bit different. Schematic actually reverses these lines. So we can just project this over. And let's do the same thing as this one, but let's just change it up just because we want to. So this is going to go 0.25. And this is actually going to be the thread. So we're going to do this and this. Oops, did I go to the wrong spot? I did. Sorry about that. Hold on. We need to go to the minor diameter. So we're going to the minor diameter here. And I think I have a projection layer here. I'll bring these over so you can see it. So this is the minor diameter there. And now I'm going to bring over the major diameter. And so from here, we're going to grab our hidden line, and it's going to be reversed. And the section for the hatch is actually going to go over top of these. But let's say it's the same thing. So then we got to show this depth. So 0.25. Go down. 0.25. Go 60 and 60. And again, we're showing the drill out first, right here, and then this hidden line and this represents the actual thread. And remember, these are just representations. What's really important is this, right here, because that's going to tell the machinist or whoever's doing this thing, that's what they need to make. But, you know, when you're looking at a drawing, you can clearly see, because you have some experience, and say, hey, that's a thread. That needs to be a thread. And these need to be longer. That's bugging me. I'm going to add another 0.1 to it. And there you go. So then when you thread it, and this is the, I mean not thread it, but when you hatch it, come in. Switch this over. H enters hatch, by the way. And it doesn't like me. Alright, there we go. Hatch, and you gotta hatch in these little gaps right here. I know it looks weird, but you should always have your hatches nice and thin. Oh, that didn't work. Come on, buddy. There we go. So it's gonna look like that. So that's an internal simplified thread. Get rid of these projection lines. And then, what does it look like from an end view? Well, you're going to have your box like so. Basically, I'm going to copy this over, and basically what happens is it reverses. It reverses the roll. So this one becomes visible, and this one becomes hidden. And that's it. And it'll be the same for these. So if you just want to copy this down, even though the box is not the right size. I'll fix that. AutoCAD is just such a nice tool. And there you go. You got your detailed, you got your schematic, and you got your simplified. Updated video, but there it is. A little bit long, but progress.